We're all taught to think of evolution as this grand biological drama, right? A story all about survival, adaptation, claws, and teeth. But what if I told you that's just the surface story? That the real driver isn't biology at all? Today, we're going to pull back the curtain on this idea that evolution is really just physics, wearing a clever disguise.
All right, let's just jump right into the deep end with something that, well, it just looks impossible. Billions of years ago, you have one simple cell that swallows another one. Now, normally, that's lunch. End of story. But in this one case, it didn't digest it. Instead, it put it to work. It turned its would-be meal into a permanent internal power pack, what we now call the mitochondrion. I mean, that one event changed the course of life on Earth. It feels so clever, so engineered. You have to ask, right? How could that not be a work of design? And that's the central puzzle right there. Our source material calls this event endosymbiosis, the absolute poster child for those moments in evolution that just scream intelligent design. It looks so purposeful. But what if our intuition is completely wrong? What if this incredible leap forward wasn't a brilliant choice, but was actually the exact opposite? What if it's one of the best examples we have of raw physics just doing its thing? Okay, so to really understand how this could happen, we kind of have to throw out the rule book we all learned. Forget survival of the fittest for a second. The real game life is playing isn't some epic battle. It's more like cosmic accounting. It all boils down to managing energy. And the key idea here has a fancy name, thermodynamic viability. But don't let that scare you. All it really means is that fittest doesn't mean strongest or fastest or smartest. The real winner in the game of life is any structure, any little pattern that gets good at managing energy and, crucially, exporting chaos, or what physicists call entropy. It's about staying stable. See, nature doesn't actively pick winners. It just lets the unstable stuff fall apart. And it all follows 4 super simple rules. Rule 1, grab some energy from somewhere. 2, use that energy to keep your own house in order, to maintain a low internal entropy. 3, shove all your mess, all your chaos, outside of yourself. And 4, make copies of the pattern that's good at doing the first 3 things. That's it. That is the entire game of life. No foresight, no grand plan, just physics. All right, so keeping those 4 rules in mind, let's rewind the clock. Let's go back billions of years. Early life is chugging along, doing its thing, but it's about to hit a massive physical wall. I'm talking about an ancient energy crisis that put a hard, non-negotiable limit on how complex life could ever get.
So here was the fundamental problem. These early cells, they made their energy on their skin, their outer membrane. That's their power grid. So their energy budget scales with their surface area. But all the important stuff, the DNA, the proteins, the machinery, that's all inside. It fills up the volume. And here's the killer math. As you get bigger, your volume grows way faster than your surface area. It's like building a gigantic factory but only having enough outlets to power a small workshop. You just can't scale up.
And the result of that? A hard ceiling on evolution. Life was stuck. It couldn't get more complex. Not because it ran out of genetic ideas, but because it simply didn't have the juice. The power was out for any ambitious new projects. So what do you do when you have an energy crisis? You find a new power source. And that, right there, brings us back to the big merger. But this wasn't some hostile takeover planned in a corporate boardroom. It was just a clumsy, accidental, physical shortcut. A loophole that turned out to be a much more efficient way to manage that pesky entropy.
But hold on. That brings up the most obvious question, right? When one cell swallows another, it's supposed to get eaten, digested, game over. Why didn't that happen here?
Well, it turns out digestion just isn't 100% foolproof. Sometimes the prey is just too tough to break down. Other times, the predator's own digestive system is a little bit, well, crappy. And sometimes, and this is the key, the waste products from the prey actually turn out to be useful for the predator. These aren't miracles, they're just glitches in the system. And you gotta remember, for every one time this works, it probably fails millions of other times. But for physics to change the world, it only needs to work once.
And that's how a 1 in a million glitch starts to become permanent. Over huge stretches of time, these 2 cells start depending on each other. They even start swapping genes. Pretty soon, trying to separate them would be energetically impossible for both of them. The quote from our source puts it perfectly. It's like a river carving a channel. At first, it's just a little trickle, but once that groove gets deep enough, the water has nowhere else to go. It commits to the path. The merger gets locked in, not by a choice, but by the sheer force of physics and history. And the consequences of this one single event, they were planet-altering. This merger didn't invent complexity. The potential was already there. What it did was provide the power. It was like it just blew the roof clean off the building that was holding evolution back.
Think about it. Instead of one power grid on your skin, you now have thousands of tiny, hyper-efficient power plants packed inside you. The available energy just went through the stratosphere. And suddenly life had the budget for all the really expensive R&D projects. We're talking larger genomes, ridiculously complex regulatory networks, cells specializing to form tissues and organs, and yeah, eventually, brains.
And this is so important. None of this was planned. There was no blueprint for a brain, no schematic for an eyeball. The only thing that fundamentally changed was the power supply. The lights were finally on, and evolution could wander into the workshop and start playing with all the cool, energy-guzzling new parts.
So that brings us all the way back to where we started, back to that big question of design. We've seen the physics, we've seen the hard limits, and we've seen the mind-blowing consequences of breaking them. So, what's the final verdict?
Well, when you actually look at the evidence, the comparison is pretty stark. Real design implies foresight, right? A clean blueprint, everything optimized. But when we look inside our own cells, what do we actually find? The total opposite. We find a messy, sloppy, cobbled-together history of this ancient merger. We find junk DNA, leftover redundant genes, clunky, inefficient pathways. These aren't features from a blueprint. They are the scars of a long and messy history. You can actually boil this whole incredible event down to a simple physics recipe. All you need are 3 ingredients and 1 process. Ingredient 1, a persistent energy source, like a sun. 2, a messy soup of different kinds of self-contained compartments, like cells, all bumping into each other. And 3, those compartments have to have some existing differences in how efficiently they use energy. Now, you just let that cook for a few million years, and the relentless filter of physics will automatically favor the combinations that are more stable and better at dissipating energy. And here's the kicker. When you have those simple conditions playing out on a planetary scale over hundreds of millions of years, the result isn't some lucky 1 in a trillion accident. From a purely physics standpoint, a stability-enhancing merger like the one that created mitochondria wasn't just possible, it was pretty much inevitable.
And so we land on this final, really powerful thought. The breathtaking, intricate complexity that we see all around us in the living world, it isn't the work of a grand designer. It's just the brute force result of physics finding a more stable, more efficient path for energy to flow through matter. It is, quite simply, inevitability wearing the very, very convincing mask of intention.